All right, if you're here, you're back for another Math 1. This is going to be Unit 3, Lesson 1, Getting Ready for a Pool Party. And this is the homework helper. We're going to jump right in. Unfortunately, this first one here is broken down where it's here at the bottom of the screen of the first page, but the coordinate plane is actually over here. So we've gone through and already rewritten things, so we can have them there. This is simply just going through and plotting y equals mx plus b a couple times. We've gone through and color coded it already, so our h of x is going to be 2x plus 1. So we're going to go to our positive 1, put a point, and then our slope is 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, so on and so on and so on. And we'll go down to over 1 here just to kind of show. And we're going to draw through and connect them through. We're going to switch over to pink. We're going to do j of x is equal to negative 1/2 x plus 1. So same thing. They're going to start here at positive 1. We're going down 1 over 2, down 1 over 2, down 1 over 2. We go back to the starting point, go up 1 over 2 to go to the right, just to kind of fill that out there. And we're going to go through and ballpark, go there. Now, in these problems, it also asks us to describe the similarities and differences in the graphs of these two functions. You guys should know by now. I'm not going to hand write all of that. We're just going to go through and talk it through. So in this case, we both functions end up having the same y-intercept. In our blue function, it has a positive slope. This is the differences. In the blue function, h of x, we have a positive slope, and in the pink function, j of x, we have a negative slope. One other thing that you might be able to notice if you're looking for kind of a similarities, kind of a difference, is that these slopes are negative reciprocals of each other, which means that they're perpendicular. It is not something that we have talked about yet, something that you may remember from when you previously saw this. So moving on down, that was to problem 3, is we have another two functions. We have m of x and n of x, which we're going to use the same colors here. We're going to say that m of x is blue and n of x is pink. So we go graph our blue. We're going to, it's negative 4x plus 5. We're going to go plot 0, 5, 1, 2, 3, 4, 5 as our y-intercept. We're going to say down 4 over 1 as our slope. Down 1, 2, 3, 4, over there. 1, 2, 3, 4, over there. Then we can go through and just connect them through. To get something ballpark like that. Our pink, however, is going to be negative 4x minus 3, which means that our starting point is at negative 3, or 0, negative 3. And then we have the same slope, down 4 over 1. Oh, we got to go the other direction, so up 4 over 1, up 4 over 1. And when we do that, we connect them to get ballpark there. I apologize, mine's not perfectly straight. It auto-corrects my stuff. But it does ask us the same question here, part B. It says describe the similarities and differences of these graphs of these two functions. In both of these, they clearly have different y-intercepts, unlike the last problem. They do, however, have the same slope, which makes them parallel. It means that they both have the same slope. In this case, it's negative 4. Cool. All right, moving on to problem number 4, which is the next page. 4 and 5 on this page, is we get to go graph these functions. We're continuing to do the same thing. So when we go graph this, remember we've got, oops, let's go blue here again. Let's go pink here again. Anytime we've got some letter of x, it means that just means y. So in this case, we have y equals negative 4 and we have y equals negative 1. So we're going to go graph 1, 2, 3, 4. Negative 4. And then it's just a straight horizontal line. We do the same thing at negative 1 for q of x. What we get there. So once again, different y-intercepts, just like the last problem. They are parallel. They each have a slope of 0 in this case. Please remember that a horizontal line is a slope of 0, whereas a vertical line is an undefined slope. Cool. Going down to problem 5. I've already kind of started this one in a weird way, where I built a small table to the right. Once again, we'll say r of x is blue, s of x is going to be pink. So when we look at this blue one, we have to come up all of a sudden, this is our first function that we're looking at that isn't going to be a linear equation. Now, from previous chapters, we do know that when we have a variable or x specifically, a variable up in the as a power, we know that's going to be some type of geometric and create an exponential function. So in this case, we're going to go through and I'm going to quickly just take these numbers that I have over here, this x, -1, 0, 1, and 2, and I'm going to go through and just plug those in to r of x. So I plug in -1 up into x, and I get 1/3 plus 1 is equal to, oops. And for the sake of this, we're going to say it's 1 and 1/3. I normally would never do that, but just for the sake of graphing, it just helps us out instead of having them be improper fractions. I plug 0 in, I go through, I get 1 plus 1 gives me 2. Plug in 1, I get 4. Plug in 2, I get 10. Probably going to be able to graph that, but we're going to see. So we go through and we want to graph this. We get -1 and 1/3. The ballpark's going to be there. 0, 2, great. 1, 4, 2, 5, 6, 7, 8, 9, 10, all the way up to there. So in this case, we're going to start seeing some exponential thing that ends up looking like that. For s of x, which is our pink, we're just going to look at it and say, all right, we've got a y-intercept of +2. Oh, glad they share something. And then a slope of 2 over 1. So up 2 over 1, 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 so on and so on and so on. So I can graph those here. Now, if we're looking for similarities with these, yes, they have the same y-intercept at 0, 2. However, the difference is here is that our pink function, our s of x, is a linear function. Our r of x, our blue function, is going to be a geometric or an exponential. So keep that in mind. Let's see. Awesome. We're going to go over to... All right, this problem, once again, is broken down into a weird thing on mine, so I'm actually going to read from the paper here just to make sure that we can have this. This one here, we're going to be given a handful of graphs. We're given 5 graphs. We're given 5 different kind of situations. First one is actually, we're not going to do that. We're going to skip. You guys can read through those on your own. Pause the video. I'm going to go over here to the actual 5 graphs. And we're just going to go through and we're going to talk about each one of these. And so for problem number 7, what we ended up getting was that this is going to be B, as in boy. The reason behind that is because B is the temperature of an oven on a day that mom bakes several batches of cookies. In graph number 7, I'm sorry, in number 7, if we look at this, it's a continuous function that's going up and it's rising and then falling and rising and falling and rising and falling throughout the entirety of it. The way that we can go through and say that this is B is that every time mom or somebody else opens the oven, we go through and it lowers the temperature. And then we put more cookies in, it rises back up. We open the oven, it drops back down, but notice it doesn't go all the way back down to 0. It's continuously being used throughout the day. So that's a good one for that one there. For problem 9 here, we said that this was D as in David. And in that context, it is watermelons are delivered to a farmer's market every Saturday morning. The number of watermelons available for sale on Thursday. So we're delivered, 100. We sell 1. Great. That's why it skips here where we're seeing this gap is because it's not continuous. We are selling 1 at a time. We're saying, all right, we sold 1. We sold 2, 3, 4, 5, 6, so on and so on as we're working our way down. Doesn't matter how many original were there. There's no Y or X values here. So that one there, it is a discrete, and it is going through and it's lowering throughout the week, which makes sense because if we're selling watermelons, we're likely going to be, we're going to hopefully end up with a lot fewer than we started with. And our last one here was problem 11. Problem 11, we're saying that this is going to be C. C is the amount of gasoline on hand at the gas station before a tanker truck delivers more. If you think about any time your parents have gone through and filled up at the pump, it doesn't just go through and immediately fill up. They sit there, they hold the thing, or they lock it in place. This means that it's continuous. as we're going through, it goes through and we're saying, all right, there's an X number of gas in the pump. The first person goes and uses it. Boop. The next person shows up and uses it. And then it sits there, and then people keep going. Oops, that wasn't supposed to be a straight line. And we're going to end up getting to there. Sorry, that was not what I wanted to do. So in this case, before the tanks are empty, it's slowly going towards zero, but it's going to plateau and then drop as people fill up their tanks. Cool. All right. Moving on to the next piece here is we are looking at problem 13. We go over to 13 here. 13, there's a couple different things. Let's go through the instructions. Given the paragraphs on each coordinate grid, create a list of similarities the two graphs share and a list of differences. We're going to talk about those here for problem number 13. Once again, just going to talk you through it. In this case, they both appear to be linear, or as close to linear as possible. They're both positive. Not perfect, so don't hold that against me. But they're both have a positive slope. They are, one is discrete, or one here is discrete. It's broken up. Versus our continuous, which is the one on the right. They each have different X and Y values. So they're not sitting on top of each other. We can't say, hey, the slope is exactly the same, but we do know that they're going in the same direction. They're moving upwards to the top right, so we know that that's going to be positive. So that's just a couple of quick things for that. And yeah, so moving on to the last little section, there's two short problems here. We've got problem 14, which is 10 to the x power. So we're old school solving here. For each equation, find the value of x that makes it true. In this case, you guys are just looking to plug in values. 10 to what power is going to give us 100,000. In this case, anytime you have a problem like this and you have 10 to a number, just go through and say how many zeros are there going to be at the end. So in this case, without doing a whole lot of thinking and guessing, we can go through and say, all right, we've got 1, 2, 3, 4, 5 zeros. So if we were to go to this, plug in 5 here and say 10 to the 5th power, we're going to get 100,000. So x is equal to 5. For problem 17 here, it's a linear equation just going through and trying to isolate x. We're going to add 8 to both sides. We do that. I'm going to go right over here. We have 5x is equal to 45. Divide both sides by 5. We get x is equal to 9. Cool. So that's another edition of some Math 1 homework helpers. If you have any questions, please stop by. See your teachers. All right. Take care.